Here we're going to look at question 27 from section 2 of the BMAT 2018 paper. So in this question we're told some things about carbon-14 and radioactive decay. So first of all we're told that we have 10 to the 3 carbon-14 atoms for every 10 to the 15 carbon-12 atoms in living material. We're told that this ratio stays constant inside living material, but as soon as the material dies, the amount of carbon-14 begins to decay. It does this with a half-life of 6,000 years. So, in a bone, which we're given, we're told that the ratio of carbon-14 to carbon-12 is 10 to the 2, to a ratio of 10 to the 15. So, what the question actually asks us to do is to find out how old this bone is, the bone with the ratio of 10 to the 2 to 10 to the 15, and of carbon-14 to carbon-12. So if you'd like to have a go at this question yourself, then please pause the video now, otherwise let's have a go at it together. Okay, so let's think about the information which you've actually been given in this question so far. We've been told that normally we have a ratio of 10 to the 3 to the power to the 10 to the 15 of carbon-14 to carbon-12 atoms. But we've been told that in this bone we have a ratio of 10 to the 2 to the 10 to the 15 of carbon-14 to carbon-12. They've also been told that after something dies, carbon-14 decays with a half-life of 6,000 years. So basically what's happened is that our bone was initially with a ratio of 10 to the 3 to the 10 to the 15, but over a period of time it's decayed down from 10 to the 3 to 10 to the 2 number of carbon-14 atoms. So with this we can try and determine how old the bone actually is. Now the easiest thing to do in this case with half-lives generally is just to count down from them. So we know that initially we started off with 1,000 carbon-14 atoms for every 10 to the 15 carbon-12 atoms. So after the first 6,000 years, we know that this is going to reduce to a number of 500. And then after another 6,000 years, we'll have 250 for every 10 to 15. And then after another 6,000 years, 125. And then after another 6,000 years, we'll have 62.5 for every 10 to 15. But this is further than we're actually looking for. We're looking for how long it takes to reach 10 to the 2 or 100. So 100 is going to be somewhere in here. Now, getting to a total number of 125 for every 10 to 15 carbon-12 atoms has taken 18,000 years. So to get to 100, it's just going to take a bit more than 18,000 years. It's not going to be as many as 24,000, the extra 6,000 years on. So it should be just something a little bit more than this. Now, if we look at the answers we're given in the question, then we can see the closest answer is actually just going to be 20,000 years. So this is the correct one, and it's going to be answer E.